highest point of the initial orbit and raises Dragon's perigee, or the lowest point, to a higher altitude.
The next burn, which is based on what our orbital data shows us, is the boost burn, which will raise Dragon's orbit until its orbit reaches an altitude of just 10 kilometers lower than the space station. Its orbit to just 2.5 kilometers below station. And we round everything out with a final co-elliptic burn to once again maintain a constant orbit beneath station, just 2.5 kilometers below.
Then we'll get into the approach initiation and the final stages of Dragon's rendezvous with the space station. This is also when we start integrated operations between the Dragon control team here in Hawthorne and the space station flight controllers in Mission Control Houston. The teams will transition to integrated operations roughly 45 minutes prior to approach initiation. During the approach, SpaceX's flight controllers will work in tandem with the NASA team in Houston to activate and test out a number of systems on Dragon, including bidirectional communication with the station using the C2V2 system, which stands for Common Communications for Visiting Vehicles, and sets up a data stream from Dragon to the station, giving another path for Dragon telemetry to come to the ground and giving additional command capability to astronauts aboard the station. They'll also maneuver Dragon to the proper attitude and initialize the navigation sensors used for the methodical approach to the station.
Tomorrow at approximately 2:40 a.m. Pacific Time or 7:40 GMT, Draco thrusters on Dragon will fire for the approach initiation burn when Dragon is about 2.5 kilometers below station and just about 7 kilometers behind it. This will swing Dragon up until it's about 400 meters directly below the station. This maneuver will also move Dragon inside one of the two safety zones around the station that requires a set of go-no-go poles with the different control teams. The first zone is called the approach ellipsoid, which is an imaginary shape measuring 4 by 2 by 2 kilometers, essentially a large three-dimensional oval. Before Dragon is given permission to move inside this ellipsoid, referred to the teams as AE, it is configured to be on what is known as a 24-hour safe trajectory. This means that if Dragon lost...
Dragon SpaceX, we are go for the burn.
Endeavor copy, go for the burn.
And we heard a call out that we are go for that first burn. Now this means that if Dragon lost all control to its thrusters, it would be at least 24 hours before its orbital path would take it inside the approach ellipsoid.
So once Dragon arrives at 400 meters below the station, it will be at waypoint 0, which is the first checkpoint during our approach. The vehicle can hold at 400 meters or continue on if all systems check out on the approach to waypoint 1. By this point, the teams will do a go-no-go poll for Dragon to move inside the keep-out sphere, another zone that consists of an imaginary sphere around the station with a radius of 200 meters. It's another chance to confirm all of the guidance, navigation, and control systems are working correctly on Dragon before moving closer to the station, and carries a requirement similar to the AE that Dragon's orbital trajectory would not bring it inside that sphere if control was lost. But this time only for 4 orbits, or about 6 hours, instead of 24 hours.
Dragon's move from waypoint 0 to waypoint 1 will swing it up and out in front of the station, pausing at a distance of approximately 220 meters. At this point, it will be on what we call the docking axis, which essentially means it is directly in front of the docking port. The crew is headed to the forwardmost port on the International Space Station, the Node 2 forward port. That is where Dragon docked for both our demonstration missions as well as Crew 1 last November. For those following along, Resilience, the Dragon spacecraft used for Crew 1, recently moved from the forward port to the space-facing port on the Harmony module in order to make room for the arrival of Crew 2. Harmony, or Node 2, is where both of the international docking adapters are located. These were installed for new commercial spacecraft flights and any other future spacecraft that also use the international docking standard.
Now, once Dragon is only 20 meters away at waypoint 2, the spacecraft focuses on aligning its docking system with the docking adapter. Dragon will then fly in and make contact with the docking adapter, giving us what we call a soft capture. The soft capture ring then retracts until sensors indicate it's time for hooks to drive in place to give us a hard capture and firmly secure Dragon to the station. Then it's time for leak checks and hatch opening, which is currently timelined to come about 2 hours following docking.
So we have a lot of action to cover over the next 23.5 hours. So let's head down to Mission Control Houston and check back in with Courtney Beasley to get a rundown of all the work being done on station to prepare for Dragon's arrival. How's it going, Courtney?
Thanks, Jesse. A lot of prep work went into this day to make sure we were launching Dragon and this new crew to a fully functional orbital laboratory. Several hours before the crew boarded Dragon, the space station team did their go, no-go poll. There are several key systems we have to ensure are fully functioning before NASA can give their go for launch. And one of those more obvious is making sure our life support systems are functioning normally. This includes the ability to turn water into oxygen for the astronauts to breathe, the ability to remove carbon dioxide exhaled by the station crew into the atmosphere, and our water recovery system, which is now able to recycle about 90% of the water we send to the station. The teams also made sure there were no issues with the station's power or cooling systems.